Chapter number 5. It is Standard 12. Semester 3. Subject Max. Chapter number 5 is Continuity and Differentiability. So in 11 science we have learned limit and differentiability. Okay. Now here we are going to learn continuity at a point, continuity in an interval. Okay. Continuity and differentiability. How do I define continuous function? So in 11 science you have learned different type of function and their graphs. And you see the graphs of trigonometric function are smooth graphs. They are called continuous. Trigonometric function are called continuous function because their graph is a smooth graph. They are not broken at any point. Once we start drawing the graph, it is a smooth curve. Without lifting or your pencil or hand, you can draw a smooth curve. Some functions are not continuous. See, fx is bracket x, you have learned. They are broken at 0, 1, 2, minus 1, minus 2. So they are not continuous for all x belongs to z. So indirectly you have learned continuity geometrically. That continuity matlab graph are smooth curve. They are not broken at any point in the given domain. Then function is said to be continuous in that domain. I define continuity algebraically. What do you mean by continuous function? Let f is a function defined on an interval AB, open interval AB, containing C in it. C belongs to R and C is a member in an open interval AB. If function f is continuous at C belongs to open interval AB, then you should check three conditions. Limit x tends to C of x must exist. Matlab its right-handed limit and left-handed limit must exist. Second, f of C must exist. Matlab fc must be defined. And third is limit x tends to C of x must be equal to fc. Matlab limit x tends to fx, matlab limit x tends to C of x is not equal to any finite number. It should be equal to value of function at C. If these three conditions are satisfied by any function, then I can say that f is continuous at C. Let f is a function defined on open interval AB to R. Let C belongs to AB. If first limit x tends to C, fx exists, means its right-handed limit exists, its left-handed limit also exists. You learn this everything in your 11th science, right? Both limit exist and both are equal. Then we can say that limit exists. Limit x tends to C fx exists means its right-handed limit also exists, left-handed limit also exists and both are equal. Second condition, fc is defined. Matlab fc, value of fc is defined. Matlab fc is not something upon zero form. Okay. And third is limit x tends to C fx. Limit and fc sorry. Limit x tends to C fx and fc both are equal. Then function f is said to be continuous at point C. belongs to AB. If function f is said to be, if function f is continuous for all C belongs to open interval AB, every point on in open interval AB, if function f is continuous for all C belongs to AB, then we can say that function f is continuous in its domain or continuous in open interval AB. Matlab, if I draw the graph of y fx in open interval AB, it should be a smooth curve, unbroken graph. Graph is not broken at any point C belongs to AB. Right? Function f is said to be continuous on closed interval AB. Function f is said to be continuous on closed interval AB if, number 1, it should be continuous in open interval AB. It should be continuous in open interval AB, okay? Also, second, it is continuous at A from right hand side. Right handed side, limit x tends to A plus fx is fa. That is, f is continuous at A from right hand side. Less than A par to it is not defined. So, second condition is limit x tends to A plus fx is fa. Matlab f is continuous at A from right hand side. And third, limit x tends to B minus is fb. That is, f is continuous at B from left hand side. Then f is said to be continuous on closed interval AB. Clear? So we define continuity at a point, we define continuity in open interval, and we define continuity in closed interval. Now, under what condition f is discontinuous? Discontinuous function किसको बोलते हैं? Discontinuous function. Discontinuous function मतलब geometrically I can say that function is said to be discontinuous at C belongs to open interval AB if the graph at axis C is broken. But algebraically, function f is said to be discontinuous at C belongs to AB if it is not continuous at C. Not continuous at C. Now, not continuous C matlab out of 3 conditions, any one condition is not satisfied, any 2 condition is not satisfied, then I can say that function f is discontinuous at C. See, first situation, suppose limit x tends to C, fx does not exist. Does not exist matlab, suppose its right handed limit exists. Exist. Suppose first condition, suppose its limit does not exist, matlab its right handed limit exists. बराबर? But limit x tends to C plus and C minus fx exist. Both right handed limit exist, both, but nahi, and its left handed limit also exists. but both are not equal. Both are not equal. Then I can say that limit does not exist. Then also function f is said to be discontinuous. Or suppose second situation, limit x tends to exist, x tends to c fx exist, f exist, but both are not equal. Then also I can say that function is not continuous at C. Okay? Clear? So, function is discontinuous at C if its right hand limit exists, left hand limit exists, both are not equal, matlab limit does not exist, then f is not continuous. Or if limit exists and f exists but both are not equal, then it is discontinuous. Or suppose limit x tends to fx exists, c fx exists, but fc does not exist. So under this situation, in all three situations, I can say that f is discontinuous at C. So function is said to be continuous at C for that all three conditions should be satisfied. मतलब shortly अगर लेना चाहते हैं तो you should check only this. Altogether I can write if limit x tends to C plus fx is equal to limit x tends to C minus fx is equal to fc. If these three sides are equal, then all three conditions are satisfied. If this is happen, then f is continuous at C belongs to AB. Okay? Clear? AB is an interval of R. Okay? See, as we have a working rule for limit, we have some working rule for continuity also. For continuity, we call it as a theorems of continuity, but we are accepting it without proof. Okay? We are accepting it without proof. What are those working rules? See, first, I can say if f and g are continuous at C, if both function f and g are continuous at C, and k belongs to R, then first result is f plus g is continuous at C. F minus g is also continuous at G. Second, k into f is also continuous at C. Third, f into g is also continuous at C. Fourth, f by g is also continuous at C, providing g is not 0. GC should not be 0. GC should not be 0. Clear? K by G is also continuous at C. All these are called working rule of continuous. We are accepting with proof. Now some important results. This all you should remember without proof. Important results of continuity. What are the important results? Number 1, rational function are continuous on its domain. Sine, trigonometric function are continuous in their domain. Right? Sine, cos, tan. First, rational function are always continuous. Are always continuous in their domain. Second, sine, cos, tan are also all trigonometric function are continuous in their domain. Okay? Clear? Then composite function. You know, suppose f is a function from a to r. G is a function from a to b and g is a function from c to d. Range of f is subset of domain of g and range of g is subset of domain of f. Then both f of g and g of f exist. F of g is a function from domain of g to codomain of f. Right? And g of f is a function from domain of f to codomain of g. That you have learned. Okay? Suppose now I will take f is a function from r to r and g is a function from r to r. So how can I define f of gx? Is f of gx, okay? For every x belongs to r. If I say f is g is continuous at x belongs to r, f is continuous at gx belongs to r, then f of g is continuous at x belongs to r. Okay? At x belongs to r. If f is continuous, g is continuous at x belongs to r and f is continuous at gx belongs to r, then f of g is always continuous at x belongs to r. These are the important results of continuity. We are accepting it without proof.